Welcome to the very beginning of physics. Before equations, before labs, physics began with curiosity. And the best way to understand it is to imagine what people thousands of years ago might have wondered. Imagine living thousands of years ago. There were no lights, no clocks, no maps. Humans had one job every day: survive. They needed food, so they watched where the rivers flowed and how crops grew. They needed shelter, so they observed how logs rolled, how fire spread. They needed to plan, so they tracked the sun and moon to know where seasons would change. From survival need to pure curiosity, they asked questions. Why does a stone always fall? Why do shadow moves during the day? Why do rivers always fall downhill? These questions were the very first seed of physics, a mix of curiosity and necessity. What's one thing around you today that you really want to understand? Humans quickly realized noticing patterns could save their lives. Farmers learned that the sun rising at the same time every day helped them know when to plant seeds. Hunters noticed that rivers flowed downhill, so they could predict where animals might come to drink. Builders saw how rolling logs and stones behaved, helping them to move heavy objects efficiently. Physics started not in labs but in everyday life, with humans asking, "How can I understand and predict the world to survive better?" Every observation led to question about change and cause. If fire rises, why does smoke goes up? If a tree branch swings, why does it stop eventually? Human needed cause and effect understanding to plan and survive. Knowing that a falling stone could hurt helped them avoid danger. Understanding that fire burn helped them cook and stay warm. This is why physics began. Not just curiosity, but curiosity guided by practical needs. Drop different objects and notice how they fall. Which fall faster and why? Noticing pattern wasn't enough. Humans needed way to measure them. Why? To know how long it takes for a sun to rise. To know how far river flows. To know how fast an animal moves. If we come to history, Egyptians used sundial to track the day. Babylonians used water clocks to measure hours. Greeks measured distances with ropes and rods and even tracked the planetary movements. From these, they discovered distance, time, and speed, early quantitative ideas that would form the foundation of motion. Work 5 steps every second. Count step for 5 seconds. Then, distance will be speed into time. With the observation and measurement, humans could experiment and predict. Roll stone down the slope of different steepness. Notice speed changes. Throw objects of different weights. Notice distance changes. Swing logs or branches. Notice how far or fast they move. For these experiments, the first motion pattern was discovered. What do you think will happen if the slope is steeper or if the stone is heavier? Though centuries, humans tried to explain motion. Aristotle said objects stop because it is their nature. Galileo rolled ball on inclined plane and carefully measured distance and time. He realized objects don't stop on their own. Friction and obstacles stop them. From survival questions to experiments, humans slowly discovered the laws of motion. Everything we learn about motion today, inertia, force, acceleration, come from this long chain of observation, need, and questioning. So, today, we learn physics start with questions, both practical need and curiosity. Observation help human notice pattern. Measurements help human quantify this pattern. Early experiments let human predict and understand motion. Next time we will begin with the motion itself. Inertia, pushes and pulls, and acceleration using all these foundations. Think about it. If you wanted to understand why swings stop or why your toy rolls only so far, what would you do first? Observe, measure, experiment? That's exactly how physics began.